Hello friends, few days back I uploaded one video on transient response of first order RL circuit, and what I see, more than 1000 students have seen that video. That means that video must have been helpful and useful for the students. Today I will discuss about the transient response of first order RC circuit. The transient response of first order RC circuit is nothing but xt equal to x infinity minus x0 plus e raised to power minus t by tau. This is the general response. X is the signal. It can be a voltage or current. In general, for first order RC circuit, xt is the voltage across the capacitor for t greater than 0. So, when we talk about the voltage across capacitor in first order RC circuit, so that is defined by voltage across capacitor, say it is VCT equal to VC infinity minus VC infinity minus VC0 plus e raised to power minus t by tau. Remember, VC infinity is voltage across capacitor at, that is voltage across capacitor at what? At t equal to infinity, and VC0 plus is voltage across capacitor at t equal to 0 plus. Remember, this t equal to 0 plus means the instant just after switching, that is t equal to 0 plus, and tau is nothing but that is time constant of the circuit. This is time constant of the circuit for what? For t greater than 0. Tau is the time constant of the circuit for t greater than 0. Mathematically, this is defined as tau equal to R equivalent into C. What is this R equivalent? R equivalent is nothing but Thevenin equivalent seen across the capacitor terminals. R equivalent is Thevenin's equivalent resistance. Thevenin's equivalent resistance seen across the capacitor terminals. Capacitor terminals, and for what? For t greater than 0. So this is the time constant of the circuit. So now for finding out the voltage for t greater than 0, I need to calculate Vc infinity, Vc0 plus and tau. Whatever is size of circuit, whatever are the number of elements in the circuit. Now remember one thing, when we talk about transient circuit and when you talk about this expression, there should be a single capacitor in the circuit, or if there are a number of capacitors, you should be able to replace all the capacitors by a single equivalent capacitor. So there has to be a single capacitor or a number of capacitors replaceable by a single capacitor, and a number of resistances, a DC source and a switch. The conditions for transient finding this response is what? There should be a DC source in the circuit, a switch, a capacitor and a number of resistors. So I will take the example directly for finding out this voltage across the capacitor for t greater than 0. Let us take the example, and from the example you will find a number of concepts will be cleared. So let us take the example. There is a circuit, there is a voltage source, DC source, a resistance, there is a switch, then there is a resistance like this, then there is a resistance again, another resistance, a capacitor, like this. This is the circuit. This, there is a switch. That switch is initially at position 1 and it is shifted at position 2 at t equal to 0. This is the switch. Say the value of the voltage source is 20 volt. Let this resistance is 5 ohm. Let this resistance is 5 ohm. This is 10 ohm and this is again 5 ohm. This is what you have. So you have to find the voltage across this capacitor. The value of the capacitor is say 1 farad. So the voltage across capacitor you have to calculate for t greater than 0. So conditions given are this switch is shifted from position 1 to 2. Now we have seen the general expression of voltage across capacitor is Vct equal to Vc infinity minus Vc infinity minus Vc0 plus e raised to power minus t by tau. Now I need to calculate Vc infinity, Vc0 plus and tau. For finding out these three parameters, I need to draw the equivalent circuit for different instants of time. The very first step in first order circuit is I need to find Vc0 plus. Remember, there is important point here. Voltage across a capacitor cannot change instantaneously. I repeat, voltage across a capacitor cannot change instantaneously. It means the voltage at t equal to 0 plus is same as voltage at t equal to 0 minus. So if I calculate, if I can find this Vc0 minus, I will be able to find Vc0 plus. So the very first step is to find Vc0 minus, that will directly give Vc0 plus. So I will draw the equivalent circuit for t equal to 0 minus. So at t equal to 0 minus, there are certain points to be remembered. At t equal to 0 minus, circuit is assumed to be under steady state operation. That is, t equal to 0 minus means just before the switching instant. So that means before the switching instant, circuit was in steady state operation. So circuit is in steady state operation at two instants of time. Remember, at t equal to 0 minus and at t equal to infinity. There are two time moments, there are two instants when the circuit is under steady state operation. T equal to 0 minus and t equal to infinity. And at steady state, that is 0 minus and infinity, the capacitor behaves like an open circuit. Reason is the capacitor gets fully charged and it behaves like an open circuit. So if you draw the equivalent circuit for t equal to 0 minus, I will draw it like this. At t equal to 0 minus means before switching instant, the switch is at position 1. So equivalent circuit will be like this. The switch is at position 1, this resistance 5 ohm, then this resistance 10 ohm, and you need to open the capacitor. This is 20 volt source. So this is your equivalent circuit at t equal to 0 minus. This is 20 volt. So the voltage across capacitor at t equal to 0 minus is nothing but Vc0 minus. And from this circuit you can calculate Vc0 minus. And what is Vc0 minus? You can see from this, that is voltage drop across this. You can apply the voltage divider rule, that is 10 by 10 plus 5 plus 5 into 20, and that gives you 10 volt. So voltage across the capacitor at t equal to 0 minus is 10 volt. And we know the voltage across capacitor cannot change instantaneously. Therefore Vc0 plus, therefore Vc0 plus is equal to 10 volt. So you have to remember this. Now I have calculated this. Next step is to calculate this Vc infinity, that is voltage across the capacitor at t equal to infinity. And remember again, circuit is under steady state operation at t equal to infinity as well, and at t equal to infinity capacitor behaves at steady state, rather at steady state capacitor behaves like an open circuit. And remember, at t equal to infinity the switch S is at position 2. So now the equivalent circuit for t equal to infinity becomes, move the switch at position 2 now, resistance of 5 ohm, then again this resistance of 5 ohm, then resistance of 10 ohm, and the capacitor behaves like open circuit, and voltage across capacitor at t equal to infinity is Vc infinity. So you can see now the voltage across capacitor from this circuit, there is no source in the circuit at t equal to infinity, therefore Vc infinity is 0 volt. I have obtained Vc0 plus, I have obtained 0. Now I need to find tau. So for finding out tau, I told tau is what? That is the time constant of the circuit, and for time constant of the circuit is nothing but tau is equal to R equivalent, and I told R equivalent is Thevenin's equivalent resistance seen across the capacitor terminals. So I'll draw the equivalent circuit for R equivalent, and remember, whenever circuit has dependent and independent sources, for calculating R equivalent, open the terminals of capacitor, short the voltage sources of the circuits, independent rather, short circuit the independent voltage sources of the circuit, and open circuit the independent current sources of the circuit. But remember, you have to calculate R equivalent for t greater than 0, and for t greater than 0 switch is at position 2. So now the circuit becomes like this. I have already drawn the circuit for t equal to infinity, which is nothing but instant for t greater than 0, but I am drawing the circuit again. So open the terminals of capacitor for finding out the R equivalent, and this resistance seen across the capacitor terminals is R equivalent. So this is 5 ohm, this is 5 ohm, this is 10 ohm, and you can see R equivalent is series combination of these two in parallel with this. So R equivalent is 10 into 5 plus 5 divided by 10 plus 5 plus 5. So what is the value? That is equal to 5 ohm. So you have obtained R equivalent as well. So what is the time constant? Therefore the time constant of the circuit is nothing but 5 multiplied by 1 farad, that is 5 seconds. So our job is done. We can write the expression of voltage across the capacitor directly now. That is Vct is equal to Vc infinity 0 minus Vc0 plus, that was 10 volt e raised to power minus t by 5. So this gives Vct equal to 10 e raised to power minus t by 5. That is the expression of voltage across the capacitors. Similarly, you can find the different voltages and currents in the circuit. For example, suppose you have to find the current through the capacitor in the circuit. So ICT, that is current through the capacitor, is equal to what? C dVc by dt. So C dVc by dt is nothing but, we know what was Vc, that is Vc infinity minus Vc infinity minus Vc0 plus e raised to power minus t by tau. If you differentiate it, you will get Vc infinity minus Vc0 plus C divided by tau e raised to power minus t by tau. And you know what is tau? Tau is R equivalent into C. So this is Vc infinity minus Vc0 plus divided by R equivalent is Thevenin equivalent seen across the capacitor terminals, e raised to power minus t by tau. This is ICT. So you can find the voltage across the capacitor directly by using this expression. And we have seen what was Vc infinity in this case. Here ICT is equal to, you should remember this expression directly rather than doing this in the exam. Remember this. So now Vc infinity we have seen that was 0, Vc0 plus was 10, R equivalent was how much? R equivalent was 5 ohm into e raised to power minus t by 5. That is how you can find this. So this is equal to minus 2 e raised to power minus t by 5. So that is how the current through the capacitor varies. Similarly, we can find the voltage across a resistance and current through a resistance, but what I observed in last video, that was spanning over 45 minutes, so that became lengthy and most of the students stayed just for 10 minutes, 15 minutes. So rather than making the video lengthy, I will stop here and I will make another video on response of RC circuits for calculating voltage across a resistance and current through a resistance. Thank you very much.